Hello there, Mr. Sutton here, bringing you this AB Calculus 610 lesson on rate in, rate out. The big topic here is we're going to be solving accumulation problems where a quantity is increasing and decreasing at the same time. So think of a bucket where we're pouring water in and there's a hole in the bucket and leaking water at the same time. Only we're going to have an amusement park problem. So stay tuned for that. So for this lesson, we've got some good news and some bad news, or maybe some other news. The good news is we're only going to do a single problem for this whole lesson. The other news is that it has 4 parts to it. This is a free response problem involving rate in, rate out. So let's take a look at the background story to what we're going to be doing over the next few minutes. So we have an amusement park, and the rates at which people are entering and leaving this amusement park on a given day are modeled by the functions e and L below, respectively. So the e function is for entering, the L function is for leaving, and these are both sort of rational kind of functions here. Now they're telling us both of these functions are measured in people per hour, and time is measured in hours after midnight, so that's going to be important. These functions are valid between 9 and 23, so 9 a.m. to 11 p.m. if we're doing standard hours. And those are the hours during which the park is open. At time 9, there are 10 people in the park. They stayed overnight in the super fancy hotel there. So that also might be important later on. So for the first question, we want to know how many people have entered the park by 5 p.m. That's time 17 for those of you who prefer military time. And they want us to round our answer to the nearest whole number because we don't want like parts of a person here. All right, so a good idea in general is to immediately enter your given functions into your calculator like right off the bat because you know you're going to use them. Once you've done that, pause the video and see if you can answer this first question based on what they've given us here. All right, so let me go to my calculator and follow my own advice. So let me do my e function, e of t equals fraction 15,600 over t squared minus 24t plus 160. And I don't need to graph it necessarily, so let me just deselect that. Let me also enter my L function, and that is, let me move this so I can see it. So we've got 9890 fraction t squared minus 38t plus 370. And again, I don't necessarily need to graph that. Okay, so what am I going to do with all this? Well, if I'm asking how many people entered the park by time 17, I'm asking how many people have I accumulated using this e function over the interval from, now we got to be careful here, we have to do the interval from 9 to 17. We don't want to do 0 because although people weren't entering the park between midnight and 9 a.m., this mathematical function is going to accumulate that stuff if we include 0. So we need to do total people entering equaling integral from 9 to 17 of e of t dt. And if I do that on the calculator, let me just move this so I can see what I wrote. So we've got integral int 9 to 17 and e of t dt, and that comes out to about 6,004 people if we round that off. For part B, they're introducing a new function, p of t. That's the number of people in the park at t hours. They want us to find p prime of 17 and explain its meaning in the context of the problem. So we kind of have to zoom ahead to the last part of this problem and have some understanding of what this p prime is doing. So if p is the number of people, p prime is the change in the number of people. The overall rate in the number of people in the park is going to be a factor of 2 things. We need to consider the number of people entering per hour and the number of people leaving per hour. So overall, the overall rate is going to be the rate in minus the rate out. So pause the video with that in mind and see if you can first write a function for p prime of t and then plug 17 into it on the calculator. Give it a shot. All right, so rate in is E of t, rate out is L of t. So P prime of t in general, we're going to define this as E of t minus L of t. And then the next thing we're going to do is do P prime of 17. So I'm actually going to define this on my calculator. I could just do E of 17 minus L of 17, and that would be fine. But I have a feeling I'm going to be using this function more than just once. So it's good to define things that you're going to be using multiple times. So let me call this, I'm going to call this small p of t, just so I don't get it mixed up with big P here. And that's going to equal E of t minus L of t. Let me just move this up so I can see it a little bit better. And now if I want P prime of 17, I'm just going to do P of 17 the way I've defined this on the calculator, and that's going to come out to negative 380.281. Okay, so that's the raw number. They want us to explain the meaning and the context of the problem though. So what is this? What are the units, and what's the time element that's happening here? So to get full credit for explaining this problem, we would say that we have negative 380.281 people per hour. This is the rate of change of the number of people. And it's in, again, this is in the units of people per hour, and this is happening at 1700 hours, also known as 5 p.m. For part C, they want to know at what time from 9 to 23 is the number of people in the park the highest. So we're trying to maximize our P function. So before you start doing this, just as a little bit of strategizing, consider our strategies for finding absolute maxes. We've really got two strategies. One is to basically find all the critical values and endpoints and plug them all in with the candidates test. And the other is to figure out critical values. If there's only one of them, then that critical value itself might be an absolute max. Now, in thinking about your strategies, if you're going to use the candidates test, you're going to need to figure out a function for P of t that you can actually plug things into. There is a way to do this problem, though, without coming up with that function. So pause the video and see if you can figure out how to do it in this situation. All right, so regardless of what method you ultimately use, you're going to need to figure out critical values, which means we need to know where P prime of t, which I've called P of t on Desmos, where we want to know where this equals 0. So let me go back to Desmos, and I don't need P of 17 anymore, but I've got this P prime graphed out here. Let me just change my window here. I'm going to make that go from, let's see, well, let's do 8 to 24, a little bit beyond the actual interval of the problem. So there isn't much to see right here because we're very zoomed in on the y values. So let me go to my y values and just zoom those out a little bit. Let me make this 80, 800, up, and there we go. If I make that 800, I can almost see everything here. Let me zoom out a little bit more, and I can now see a little bit more of the function. So we see that between, let's see, we said 9's right here, between 9 and 23, which is about here, we only have a single critical value. What is that critical value? That critical value, clicking on the graph, is about 15.795. I have a feeling I'm going to need to use this later on, so let me just copy that, and I'm going to let A equal that on here. So here's that picture again, and again I'm going to call on paper as well when I write out my justification. I'm going to say A equals this crazy decimal number here. Now if I was going to do candidates test, again I would have to figure out a function for P of t itself, which they didn't actually give us the whole function. We just have the derivative that we came up with ourselves. But I don't need to actually use the candidates test here. I only have a single critical value, and since the P prime is changing from positive to negative, that is going to be a local max which means this is also going to be an absolute max since there's no other critical values. So to justify this and kind of bring it home for us, what we can write on this one is that p prime of t is greater than 0, positive, on the interval from 9 to a that we just defined here, and p prime of t is less than 0, negative, on the interval from a to 23. Since p is increasing until we get to a and then decreasing afterwards, by definition, that means our absolute max must occur at time a hours, which is 15.795 hours, which is, let's see here, that would be somewhere between like 3 and 4 p.m. For the final part of this problem, they want to know how many people are actually in the park at the time we found in part C. I mean, we found when the max number of people occurs. What is the max? So when you're doing this, just something to consider. In general, total amount of a quantity is going to be the amount that came in over the given time period minus the amount that left. But there's also one important piece that we're forgetting about. We need to know the initial amount of whatever it is we're measuring that was there when the problem started. If we forget about that, then we're just kind of figuring out the displacement and not the new position, so to speak. So with this in mind, pause the video and see if you can sort out how many people are actually in the park at the time we found in part C. All right, let's see how that went. So I'm going to have to take into account the number of people in the park when everything started. So they said there was 10 people in the park at time 9. So P of A, that was our time that we found in part C. That was about 15 point something. That's going to equal 10 plus, now we're going to need an integral from 9 until time A when we actually hit that maximum number. And what am I going to be integrating? In general, it's going to be the rate in minus the rate out. We could do E of t minus L of t, but we already defined that as p prime of t. So I'm just going to use my function I defined, p prime of t dt in there. And now let me just go to Desmos and see what happens. So going back here, we've got a defined. So let me do 10 plus integral from 9 to a, and then I defined p prime again as little p in my Desmos, so I'm going to just do little p of t dt, and that comes out to about 3,961 people if we round that off. All right, so that is it for rate in, rate out, and now it's time for me to peace out. Until next time, Mr. Sutton signing off.